Hello everyone, welcome to my YouTube channel. So today I am going to discuss about the topic that is buckling analysis. So first we should know that what is buckling analysis. Okay, so see, buckling analysis is generally a finite element analysis. Okay, so buckling analysis is a, we can say that it is a finite element analysis. Okay, it is a finite element analysis in linear buckling analysis. So we can say that buckling analysis is a finite element analysis. So one questions just come in mind that either buckling analysis is a static analysis or dynamic analysis. So first we see that what is buckling. See, suppose we construct the column. So in the case of column, one end is fixed and other end is also fixed. Okay, and this is the column. So when we applied the load on the column, what happened is that it generally deflect like this. So this is called deflection, and this is load P. So P into lambda. So this is called buckling. Okay. So when we go for analysis of different types of structures, so it is necessary to go for the buckling analysis. So there are some criteria to check either we have to perform buckling analysis or not. So first we see that what is buckling analysis, and either buckling analysis is a static analysis or dynamic analysis. So just know that buckling analysis, see, buckling analysis is both, okay, static and dynamic. Okay, static and dynamic means buckling analysis can be both. It can be static and it can be dynamic. So in the case of static buckling, what happens is that, see, static buckling analysis is generally used to determine the critical load at which a structure will buckle under a constant or time invariant external load. Suppose that, see, in the case of static buckling, so in the case of static buckling, it is generally used to what? So it is generally used to determine the critical load. Used to determine the critical load. Critical load, okay, at which a structure will buckle under a constant external load. Under a constant external load. Okay, so what is the meaning of this? The meaning of this is that, see, suppose this is your fixed column, this is your fixed column, okay, and just we apply the load, and due to this load this column will buckle like this. Okay, so this is a static analysis. So static buckling is generally used to determine the critical load at which a structure will buckle. Means suppose that we are applying the load of 50 kilonewton, then it will not buckle. But suppose if load has been extended to 52 kilonewton, then it has been buckled. So that is the critical load. Okay, so static buckling is generally used to determine the critical load, okay, at which a structure will buckle under external load, okay. And just now we come for the dynamic buckling. So in the case of dynamic buckling analysis, what we do is that we generally use to study the behavior of a structure under the time variant or transient load, means external load when we apply on the structures, then it generally used to study the behavior of structures. What is the behavior of the structures? So second is dynamic buckling, okay. Dynamic buckling. So in the case of dynamic buckling, what happens is that, see, it is used to determine the what, it is used to determine, or we can say that it is used to study the determine, you can say determine, and or you can say what, to study the behavior of the structure, okay. Behavior of the structure under load. So what happens is that, see, buckling analysis is a dynamic analysis and it is a static and dynamic both. So now we come to know that what is buckling, and now in which conditions we are necessary to apply the buckling analysis. See, it is not necessary that buckling analysis is generally performed in each and every structures, okay. It is not necessary, because when we, being a structural engineer, what happens is that when you go for the analysis of the structures, there are different types of analysis you have to perform. Like I'm just giving the example of that. See, you have to perform the P delta analysis, okay. You have to perform the auto construction sequence analysis. See, you have to perform the creep analysis, okay. You have to perform the modal analysis. You have to perform the stiffness modifications factor. You have to perform the vibration analysis, okay. So vibrations analysis, then you have to perform the buckling analysis, okay. So there are different types of analysis you have to perform, but you have to come to know that in which conditions you have to apply which type of analysis. It is not necessary that you have to perform each and every analysis in every structures, okay. So just see that in which conditions we can go for the buckling analysis. See, if the, see, suppose that this is your structure, okay, and this is your height of the structure, and this is your breadth, means least breadth is also this, and breadth is also this is also breadth, okay, and this is also breadth, but least breadth, okay. So when height of the structure, ratio of height of the structure to the least breadth of the structure is greater than 4, so in that conditions you need to check the buckling analysis, means you have to perform the buckling analysis in that structure. Suppose, is there any structures whose ratio of height to the least least lateral dimensions is greater than 4, so in that case you have to perform the buckling analysis, or you can say that if slenderness ratio is greater than is greater than 4, so in that case also you have to perform the buckling analysis in that structures. Okay, I hope you got it. So now in the case of buckling analysis, what happen is that, see, other thing you have to remember that in the case of buckling analysis, okay, I'm just writing in short form. So in the case of buckling analysis, you have to consider 6 modes. Okay, you have to consider 6 modes only. Clear? You have to remember this thing. So already we know that in which conditions we have to apply the buckling analysis. See, suppose that a ratio of the height of the structures to the least lateral dimensions is greater than what? 4. So in that case you have to perform the buckling analysis in that structures. So other thing is that load combinations for buckling. Suppose that we are considering the buckling analysis in any structures, so what should be the load combinations we have to follow? So just see, I'm just writing load combination. Load combination for buckling. See, the load combination is that 1.5 times dead load. Okay, what is dead load? That is self weight of the structure. Then 1.5 times space x. What is space x? It is the response spectrum method, response spectrum analysis. Okay, and then 1.5 times buckling. This is the load combinations. Okay, this is first, and second one is that 0.9 times dead load plus 1.5 times response spectrum plus 0.9 times buckling. So this is the load combinations for buckling. Suppose you are considering the structures where you have to perform the buckling analysis, so this is the load combinations you have to remember and just apply there. Okay, so I hope you got it. So in a simple way, just if anyone will ask that what is buckling, so in simple way you can say that we generally perform the buckling analysis to check the stability of the structure. Okay, and other one question just come in mind that suppose we perform the buckling analysis. Okay, so how will come to know that our structure is safe against buckling? You perform the analysis, then after analysis you got the result. So how will come to know our structure is safe against buckling or not? So see, if buckling factor, when you go for the analysis, after getting analysis you will get the result for that. Okay, so if buckling factor, if buckling factor is getting very less means 1 or 1.5 in between. So in these conditions you have to perform the buckling analysis in design. Perform buckling analysis in design. Okay, and come to know that our structure is not safe against buckling. Okay, so this is the criteria. So after performing the buckling analysis, you will get the analysis result. So there will be the buckling factor value. So you have to check how much buckling factor value you are getting. Suppose the buckling factor value getting very less, in between 1 or 1.5. So in that case you have to come to know that you have to consider the buckling analysis in design, or our structure is not safe against buckling, so you have to modify and all that. Clear? And if buckling factor, okay, is getting more than that, either 8, 10, 12, 14 like that, so in this case there is no need to perform buckling in design, and just come to know that our structure is safe against buckling. Okay, so these are the criteria for the buckling analysis. So it is very important analysis. Okay, so first you have to come to know that which structure you are going to analyze. Is it necessary to perform buckling in that structure? So there are some formula for that. This is the formula. You have to check height by least lateral dimensions is greater than 4, then you have to perform for that. If getting less, then there is no need to perform. Okay, and second is that if the cylinder ratio is getting more than 4, so in that case also you have to perform the buckling analysis. So I hope you got it about the buckling analysis. Okay, if is there any problems to understand, kindly DM. Okay, I will try to resume the topic. Okay, thank you so much.